This is not the thing that Kevin does every single day.
We'll do it later, I promise. Okay. This is, remember, permutations are combinations with a specific order, correct? Or a specific restriction. And with the little squares, these little squares, what you put is the number of positions, right? And inside, you put the number of possibilities, okay? So if they tell you something like this, how many, find the number of odd 3-digit counting numbers, odd 3-digit counting numbers that are less than 600. Here's 3-digit counting numbers. Odd. This position here, if it's odd, only the last one has to be odd, right? Only the last number has to be odd in order to make the whole number odd. Would you agree? So the number of choices in this one in particular is 1, 3, 5, 7, 9. This one is 5 in this one here, okay? Now, in this one here, what choices do I have?
1, 3, 7, 9.
No, because it can be any number from 0 to 9. So that's 10 here, right? I can put any one of these in here, so that makes it 10 choices.
And 10 as well on the other one.
Ah, you would say 10 as well on the other one? Not really. If anything, it would be 9, because 0, you never start a 3-digit number with a 0, so that takes 1 away. That's 9. But there's a restriction, and the restriction is it's less than 600. So if it's less than 600, it means that your choices are 5, 4, 3, 2, 1. Not 0, because you don't start a number with 0. So, how many choices? 5. Does everybody see that? No. What don't you see?
Why did you start at 5?
I didn't beat. What did you start at 5 for what? For the number of choices or the number 5? The number 5, because it tells me that it's less than 600. What is the first number that is less than 600 that is largest than all the other ones? 599, right? So, it can't be 6 because it has to be less than 600. And the first less than is a 5. And you can go under that, after that. Does everybody agree? So, the total would be 250 possibilities. Does everybody see that?
Yes.
Let's do another one. Now let's do example 45.1. How many odd counting numbers can be formed? So we need odd and counting numbers so that there's no decimals, right? Can be formed with the digits 3, 4, and 5. And no repetition is allowed. So these are your only choices. How many odd counting numbers? Now, odd counting numbers, you have 1 digit, 2 digit, and 3 digit. Would you agree? That you can form with these 3 numbers. No repetition is allowed. So, in the first one, how many odd counting numbers?
2.
2. This one, I can put 2 options here, and then I have how many left? I have 2 left, right? Why do I only have 2 options here? Because they have to be odd. In this position, they have to be odd because they're asking for odd counting numbers, right? Over here, I've got 2 because it's the same 3 and 5. 2 and 1 left. Once I've used this one, I've got 1 left. So I have 2 here, 4 here, and 4 here for a total of 10 different possibilities. Is that clear? Now, if over here, let's say that no repetition is allowed.
594.
Exactly. 5, 9, 3.
3, yeah, because it's 2.
Because it could be that you used the other 2, right? If no repetition is allowed. So, this would be a completely different number. Is it clear why it would be 3, 9, and 5?
No. Not really.
No, not really. Okay. If repetition is allowed, it means you can use all of them all the time, right? So you have a 10 here and a 5 here. But if repetition isn't allowed, you have to assume that the one you pick for this one could be the same as this one. So that one takes 1 away, right?
And it takes 1 away from 5.
Now you've used 2 choices already of the 4 that you have. It could be. So that leaves you only with 3 left. Does it make sense now? And then you just multiply and get the answer, okay? We clear? Now, next topic. Using the online linear regression. Let me explain what linear regression is. We saw it already, and this is a statistical term. And it means that if you have 2 variables, you are going to find out how related they are to each other in a way that you can draw a line through them and predict the future because they behave linearly. We've seen this before, like eating a lot and gaining weight, they are very related to each other, right? Exercising and losing weight, again, very related to each other. Not washing your hair and having it stink, very related to each other, right? Not using deodorant and smell, all those are really related. Now, how about something not related? Eating gum and having your hair fall out. Not necessarily related, right? So, if you have 2 variables like that, so far we've been doing it on foot. We've been doing it, we draw the line ourselves, sort of where we think is closest to most points, and then we choose points on the line, and we find out the slope. Remember those 2 points that you would choose?
Yes, x2.
y1, x2, y2, and then you would find the slope, and then you would find the y-intercept, and you gave the line that you came up with. Wonders of technology, it can do it for you using a graphing calculator. But it goes a step further, and it gives you a really cool variable, of which there's 2. I'm not sure which one, the calculators that you get, but it's usually Spearman. You have these 2 R's. One is the Pearson R, and the other one is the Spearman. This particular moment, I don't remember which one is which, but they both tell you how correlated something is. If I'm not mistaken, and you can check this later online and correct me if I'm wrong, Spearman goes between -1 and 1, with a direct correlation if it's a 1, and then inverse correlation if it's a -1. Meaning, let's say that this is weight, and this variable here is food eaten. Okay? Amount of food eaten. And this one would have a correlation of 1, because the more you eat, the more weight you gain. I put it backwards. It's weight here, and weight gained, food consumed, amount of food. Okay, so the more food, the more weight. So if you get a correlation here, it would probably look something like this, probably. Because there's exceptions, right? There's people with really high metabolisms who can eat a lot and don't get any weight. Those are the outliers like here, right? Or they might be teenagers and you can eat a lot and not gain weight. But once you hit 40, cheap. Okay, so you might have like a dot somewhere over here. So all the dots are really together. that would be a correlation of 1. This is not necessarily 1. Let's say that the correlation for this one would be 0.97. It's like almost 1. It's almost a direct correlation. What if we have a correlation of 0? It means one variable has absolutely no influence over the other one. And if it's a negative 1, then one variable influences the other one inversely, upside down. So the more you eat, the less weight you gain, right? That would be like awesome.
Or you lose weight.
Or the more junk food you consume, the healthier you are. That would be like everybody's dream, right? Especially in the US. So, is it clear what this is? To get this is a really big formula, and when we do statistics next year, I will teach you how to do this on foot without using the calculator. Because it's interesting seeing how to do that. It's using frequency tables and a bunch of other things. But for now, just learn to see if something has a good correlation or a bad correlation. Is it clear when it has a good correlation? If it's from 0 to 1, the closest it is to 1 is a good correlation. The closest it is to 0, there's really no good correlation. There's no correlation at all. Okay? We good? How to use a calculator, I will teach without the video.